we're going to do an example. It's going to be 4 to the x plus 1 is greater than or equal to 32. I want you to solve this for x. We had a number of different kinds of examples.
You did find the, it's 2.
What is 2? You're right, but what is it?
I don't know.
The base. We need to rewrite the bases so that they have a common base. 4 is the power of 2, so is 32. So we can say 2 squared, and that's going to be
x plus 1 is greater than or equal to 32.
To 2 to the 5th.
Oh.
my goal. If this is possible, this is my easiest of all types of the examples we did. If it's possible, pay attention so you don't forget it when you go home. Uh-huh. That means the board's this way, not that way.
Yes.
Okay, so you can have 2 to this 2x plus 1 or plus 2 is less than or equal to
2 to the 5th.
to 2 to the 5th. Now that's kind of an intermediate step which you probably don't need, but
No.
once I get this part, I can drop the bases. It's 2x plus 2 is less than or equal to, or greater than or equal to
It's 1.5.
5. Simplify this, and you're going to find out that
3.
2x is greater than or equal to 3, and x is greater than or equal to 3 halves.
Oh, I have a question. If you have to divide by a negative, do you swap the sign?
Yes, ma'am. If you divide by a negative or multiply by a negative, you will always swap the signs. If you did something in a different version or different order, then you may still get the same thing. Yeah, you can do it. If you did it the logarithm way, you didn't see that the bases were the same, it's going to work out the same thing. It's good. Now, I'm not quite finished with this. You know which where came?
We just when you put 2x2 is greater than or equal to 5, where does that even come from?
You take the base. See how the exponents are here? If you can get the bases to be the same thing, you can drop the bases off and just work with the x and the exponents.
What if it's not?
Then we have to do logs. We'll do some of those in a minute. Okay, so we go to the number line. Let me ask you this. What's the domain of an exponential function?
All real numbers.
Okay. This is why you can't remember.
No, I have it right now.
It's not the point. You're not paying attention. Okay, so we have, I'm just going to get 0 there for reference. There's 1 and 2. So I have a point. Is this value open or closed?
Closed because
It's greater, less than or equal to.
And do I go left or right?
Right. Yeah, right.
So we'll go to the right. So how do you remember that? You're going to go to the one side or the other. Inequalities with the exponentials are not as bad as doing it with logarithms. The logarithms have another issue that we'll deal with in a second. Any questions about doing this? That's about all you have to do.
That's really easy.
with inequalities.
Yeah. Now, let's go back to the next example. Here we go. Try this example. Pretty easy.
No, I don't like the log way.
Shh.
Oh, Griffin's being mean to me.
Here we go. Shh. So you have rewrite it as the basis. I'll put you right here. You got 5 to the x minus 4 is greater than or equal to 5 to the 4th power. And so it works out pretty easily. I can go ahead and drop those bases, and I can work it out. Okay? My inequality line is going to look like this. And I'll shade it's greater than, so I'm going to shade to the right. Yeah. And be careful about dividing and multiplying by negatives. That's going to be tricky. You're going to have to flip your inequalities.
And it's a full circle because it has to have the equal to.
Right. Let's try logs.
my least favorite thing in the whole wide world.
Now, pay attention. The first thing that you're going to need to do here is to identify the domain. If you don't know the domain,
All real numbers greater than
Mr. Way, when we get into
listen. I don't need the comment. I need you to listen to me for a minute. I need this domain because when I go to do my inequality, the domain is going to have a part of that. If I'm not aware of that, I'm not even going to put that into my answer, and I'm going to be completely wrong. Okay, so the domain for any logarithm, just a plain log of x is always greater than 0. Not equal to, but just greater than. So if we write this out, we have to go this way, right? It's the base raised to the, so it would be 5 raised to the second power equal to x. Notice what I did. I changed it to equals.
Why?
Because which side would you put the 5 squared on? And which side would you put the x on? We aren't really sure because we're raising things to powers. So we change it to equals. Make sure that you note this. I changed that to equals.
So 25 equals
For logs, we need to do this because it's too confusing. I don't know which way to go, and there's really not a way you should go.
25 is x.
Good. So 25 is one of my critical points. I will always be given at least 2. The first one is the domain number that I start on. The second one is going to be whatever I get out of my equation. That might be 1, that might be 2 or more. In this case, we're going to go ahead and plot down my x values. The original number for the domain, in this case it's 0, is always open. Never closed, no matter what the equation says, because the domain says it's just greater than that number. It'll never be equal to, because you can't take the log of 0. So you let this work on out. That's what it turns out to be. Let me explain the bottom part. Why did I mark off the negative portion? Because I have 3 sections. I have the negative section.
You can't have a negative.
I can't do the negative logs.
Why was it below 25 and not above?
Okay? Why did we shade in between and not on the other side? What I did was I took 1, that's inside that middle range. I plugged it into my equation. What is log base 5 of 1? What's that?
5, yeah.
0. 5 to what power is 1? 0. Is 0 less than 2?
Yeah.
Yes. So I shaded wherever that 1 was
Where
located.
did 2 come from?
It's in the original equation.
Why is the dot on the 25?
Because it's not equal then or less.
The dot on the 25 is open because of that. The dot on the 0 is open because of that. Okay?
Which I want to run.
Shh, you will. Everybody understand? Okay. Let's let you try this one. Log base 4 of x plus 8 is greater than or equal to 11. You try that one. Let's see if we can kind of go through this. The first step, shh, whenever you go to solve a log, your first step is to isolate that log. You got to get it by itself before you can change its form. So we have to subtract 8, okay? And so that's kind of what we did here. Once we subtracted 8 from both sides, then you had this log base 4 of x is greater than or equal to 3. Okay? And then, so this is step 1, then step 2. You have x, because you took the log both sides. She kind of skipped the part where you log base 4 of x, or log base 4
Of 3. Log base 4 of 3, and then she exponent.
Yeah. And so basically, 4 to the third power. So basically, you could go straight from here to here.
I don't even get that.
I'm not sure what you did down here, Megan.
I was trying to show what I did.
Let me adjust that. So
I can't do it.
here we go. Here we go, watch. Once I add 4 to both sides, or add 8 to both, subtract 8 from both sides, you're going to get log base 4 of x is less than or equal to, or greater than or equal to 3.
That's what I said.
I know. This time I'm going to take 4 and raise it to the 3rd power, and it's going to be equal to x. So 4 cubed. This part, I'm going to leave it. I'm going to change it to equals. Okay, so that gives me 64 equals x. Shh, listen. Okay, so once I take that value, where did this 0 come from?
It's the domain.
The domain was x is greater than 0. Shh, listen. So that says that nothing goes below 0. Even if my x value is below 0, I can't go below 0. I've got to stay above that because it's not even in the domain. And so that's where she gets her 2 values from. And so you got, well, he has a key.
Who has a key?
What does stall?
Well, I mean, you can still see him come in.
Who has a key?
Dr. Bear.
I mean, I would still lock my door all the time.
Just give you the last segment. No. No. I'd rather not lock my door. Okay? It's usually a hazard type of thing. Listen carefully. We take the 0. We take the 64. We plot those on our number line. Okay? Because we have a question where is that between 0 and 64 or is it from 64 and bigger? This is where we have to take any number we want other than 64 and 0. I need to plug it in. I'm telling you, if you can choose 1, the number 1, it makes your life easier because the log of x, when it's log of 1, it's 0. I don't care what the base is. So if I can do that, or in the next example, yeah, I am. So we're going to check. We have to check now.
Check.
So what we're going to do is we're going to let x equal 1. So if this is true, if I plug it in and, oh yeah, that's actually a true statement, then I go up to my graph and I'm going to shade wherever 1 is. In this case, it would be between 0 and 64. If it's false, since there's only 2 options, I'll shade in the other spot. And so here's how you check it. We'd say log base 4 of 1 plus 8 is greater than or equal to 11. Well, that's 0 plus 8. Is that greater than or equal to 11?
No.
No. Because it's false, we shade it in the other spot. Now, if I wanted to double check it, you'd pick a number, say, I'd take 65 or 66 or 100, and I'd probably need my calculator at that point to make sure that it works out right. Okay? Questions about that?
Wait, so you shaded the other side?
I shaded the other side because wherever 1 was false. It's not true, so I have to shade in the other section.
What if it was true?
I would shade it.
in there.
I shade wherever it's true. Let's try another example.
Wait, why are these ones so much easier than the other stuff?
Shh. This part is easy. And we're doing easy examples right now. Shh.
Does it get harder?
Not so much. Shh. Everybody got this down. I'm going to have to erase this because Megan wrote all over where my other example was.
I remember when they invented chocolate.
All right. Shh. Quiet, please.
I love that.
Wow, this is kind of weird.
Can I do one?
Domain is 8.
It's almost the time. What's the domain?
What? What did you
No. X is what? More than or less than?
Oh, more than less than 8.
More than or equal.
The domain is x is greater than 8. I want you to tell me what happens when you do minus 8 inside. What happens to the graph?
Opposite. Flip it.
Or it goes
It moves to the left. It moves to the right.
right.
Thank you. Shh. It moves to the right.
8.
8 units. So if it was at 0, And if I shift it over 8 units, now it starts at 8 and goes bigger. If it had been reflected, then it would be at -8 and going. You have to be careful. So here's how you do it with fractions. Okay? If you come down here, if you look at it, it's already a log equal to a number. What do you do?
Exponential form.
Good. So I went straight from log to an exponential form, 9 to the 3 halves. What's the square root of 9?
3.
What's 3 cubed?
81.
3 cubed? 27. That's why I got 27 right there. Okay. We keep on going. That was hard.
That was easy.
I mean, that's not difficult.
Wait, no.
Be careful about when you have a fraction, it doesn't automatically get difficult.
Also, that's it? Wait, no, don't.
Hold on.
Wait.
Shh, shh, shh. Yes.
Okay. It's 9 to the 3 halves. Why would you?
Yes.
Why would you only raise it to the 3 and not?
9 cubed is not 27.
It's 9.
9 cubed is like 700 and something.
Shh. 27.
Listen carefully. Shh. Hey, the bells are wrong. There's no need to get ready. Shh. Watch.
Did you know your desk is broken?
Yes. Most of them are.
Mine's not.
Listen carefully. Shh. You've got this graph. I found the domain. I found what the x was equal to, the critical point. I plotted those. 0 was not a critical point, so I didn't circle it. And so I have 8, I have 35, and I have a decision. Am I going to shade between the 8 and 35? Or the 35 is bigger? I won't shade less than 8 because that's not part of the domain. You may only shade inside the domain. If you shade outside the domain, it's automatically wrong. So when you look at it, I went ahead. Look what I chose now. I didn't pick 1 to use. I picked 9. Because it would make, I couldn't pick 1 to start with, but when I picked 9, it made it a 1 inside the log. So I'm still doing log base 9 of 1, because it's 9 minus 8. I just picked one whole number inside the log, or inside the domain, which allowed me to get that value right. And then it says, oh, well, is 0 less than, or 0 greater than or equal to 3 halves? Definitely not. So I shaded greater than 35. Okay, and the inequality solution is written here. X is greater than or equal to 35. Your answers come in 2 forms. You better write it in the inequality form, and you better shade your circle. Okay? Shade your circle. Homeworks 1 through 19, odd.
On the same page. Homework?
And
I shall try to do this. I will.
That's alright.
wait, can I take the quiz?